And welcome back. So, honestly, there's a lot of really good process tips you get in some of these panel discussions. That was just one of them. And if anybody wants to watch the full panel discussion on rework, of course, it's available on the Global SMT website, but you'll have to register to go to watch it, but it's well worth watching. That's another area, Mike, that is also changing. The whole soldering area with robotic soldering coming in, laser soldering, all these types of things. It's going through a lot of change as well.
Yeah, I've seen a lot of changes in rework systems over the years, from hot air gas rework systems to IR to soldering irons and dental instruments. You know, there's everything in between. It is interesting that the amount of technology that's being poured into rework versus the amount of technology that's being poured into making sure we don't need rework. You know, there's a balance between doing it right or doing it over, right? And as the old saying goes, sometimes we don't have time to do it right, but we'll find the time to do it over. So if you don't do it right, you're going to benefit from all these great new technologies in rework.
Yeah, it's an interesting area. I mean, they're trying to automate it by, using robotic soldering, where they're trying to emulate the action of a human being. You know, one holding the solder wire, and the other one holding the tip. But it's it makes it quite expensive to manufacture. So the problem at the moment really is the cost. The cost of making these robotic soldering systems is still a little bit in the high side, but I'm sure that's going to change as time goes forward and new systems come on.
Yeah, but these robotic soldering systems don't make mistakes like humans do, like pouring way too much flux on a component and the dreaded squeeze bottle thing. They don't make those mistakes. It's people that make those mistakes.
It's very true. Once you set it up and it becomes repeatable, they just don't make mistakes. And I always remember a plant manager telling me one day, he says, even my best engineer in this plant has got 500 DPM in him. He says, my best engineer. He said, so, right. There's definitely a case for automation at times. So anyway, we're going to take a little trip now to Atlanta and visit one of the Apex exhibitors, Koh Young, who've got a brand new demonstration facility set up there, and we're going to join Joel Scutchfield. Welcome, Joel. Nice to see you.
Hello. How are you today?
We're great. It's nice to see you in your brand new facility. I mean, what is it, about a year old now, the new place that you opened in Atlanta?
Almost 2 years. Almost 2 years. 2 years in early April. Yes. Time flies, right? Of course, last year doesn't count, right?
I think we lost a year, all of us.
But no, welcome to sunny and spring-like Duluth, Georgia. It's another beautiful day, and we're very happy to be here. We are suburban Atlanta, as you mentioned, Trevor, about 40 miles from the airport. This is our new branch headquarters for the Americas, and today we're standing in our state-of-the-art demo center and hoping to show you around a bit.
Okay, well, let's have a walk around and have a look at some of the highlights of what's new in the Koh Young range.
Sure, absolutely. Let's start with the Xena II, which is right beside me here, just so happens to be, right? The Xena II is our top of the line AOI system. It's been out for a few years now, but we continue to evolve the technology, specifically from the side camera perspective. If we go back to the original Xena tool, you may recall we were using 8 projection analog moire interferometry. With the introduction of the Xena II, we're adding in the digital moire, which allows us to modulate the frequency and provide measurement results up to 25 millimeters in height. So where high height comes into play, this is a system where we're going to want to have a conversation. The other added element with the Xena II was the addition of the side camera solution, the 4 side cameras. Now, we don't promote the side cameras extensively because, truth be told, we really don't need to. Our core technology is very capable. of tight densities and spacings. Where it really comes into play, as you're well aware, is complete hidden joint, right? So if we're experiencing situations with shields, issues where the component is just completely shielded from the top-down camera, obviously we need the side camera. So that's one system that I wanted to update you on as we go through the day. And I thought maybe what I'll do is just give you. Go ahead, Trevor.
Is that a combination of 2D and 3D in the Xena II?
It is, right. So all of our AOI technology does use a combination, but as I've said in the past, we like to consider ourselves more of the 80% 3D, 20% 2D, measurement-based, of course, a true 3D, versus some of the other technologies out there, which are more of the 2.5D variety, being more of the 80% 2D, 20% 3D, if you will.
Okay. Fine. So let's move on to your next machine then. Have a look around. Sure, yeah.
Okay, absolutely. We're going to talk very quickly about the Meister series, which is our introduction for the basically semiconductor packaging industry. So we're looking at things like fan-out wafer packaging, flip chip BGA, shiny device, and basically people like OSATs, device manufacturers, even foundries to some degree. But in this particular case, we're looking at components down to the 008, 004 level at 50 micron 2 mil spacing. So very high accuracy, very high measurement resolution, down to 5 micron. And again, offering a solution now both for SPI and AOI for that particular market sector. And again, looking at things like micro cracks, foreign material, all the same types of inspections that we do in a standard AOI environment, but now in that semiconductor packaging world.
Right. I mean, a lot of the semiconductor people are working down to, as you said, the 5 micron, but they're trying to push below that to the sub 5 micron level. Are you getting much,
yes,
many requests for that?
Well, we are certainly getting requests, and I think it's safe to say the roadmap certainly has that in its mix. So I think soon you will see technology from us that does penetrate below that 5 micron level. Again, voice of the customer. That's what the market wants. That's what the market has to have.
Right. One of the other things we're seeing in the industry, Joel, is a trend towards vertical integration. We've seen a few companies recently where there'll be an EMS company, but they're starting to put clean rooms in there so that they can literally have the packaging capability inside the factory as well. Are you seeing much of that?
Well, it's hit and miss, right? So in our particular world in the Americas, Trevor, as you may well know, semiconductor is still a very small piece of the puzzle, right? But when you get to Asia and other parts of the world, obviously it's a much bigger piece of their particular business. So in those particular instances, I think there is activity along that line. Here in the Americas, we've seen some of that, but again, this is still one of those things where it's almost still niche-y. I think we see the 5G drive helping to drive some of that as we go forward. As we know, the semiconductor industry is on fire right now, having a record year, and of course, a lot of that being driven by that 5G need and even beyond. So I think you can expect to see more of that as we go forward. But again, it's always gonna be where it makes most sense, right? It won't be broad scale.
Okay. Fine. So I think the next one you were going to move on to was the Neptune, which is your conformal coating system.
Yes, actually, it's dispense technology inspection. Conformal coating is certainly a big part of that. I'll step over to this side. The Neptune series is basically a combination, again, of 2D and 3D. The 3D element utilizes a technology called LIFT, which is laser interferometry for fluid tomography. That sounds like a mouthful. It's basically low coherence interferometry, or near IR. And basically what we're doing is we're utilizing a laser through a mirrored spectrum, if you will, creating the incidence of penetration through the fluid to the board surface. From that, we can gather multiple layers of fluidic structure, if you will, and use that data to build our 3D model, much like we do with our standard AOI tools, to take our measurement readings from. So it's very unique. And again, the advantage with this particular tool is we can do those measurements at a much faster rate than the systems that are on the market today. So for example, a 4 by 4 millimeter field of view can be inspected, processed, and results provided in 10 to 12 seconds. So that gives the customer the opportunity to take more of those height measurements in addition to the 2D coverage and bubble check and de-wetting and all the other things that they're doing without slowing down the production line.
What about the thickness measurement? Because in conformal coating, the thickness of the coating is quite critical. Does that laser is it capable of bouncing off and measuring the thickness of the coating?
It is. In fact, you know, the technology approach that I just described is basically how we're doing that, using that lift technology to gather that data to build that model. And basically, we can go from 5 micron to 3.5 millimeters, depending on the actual flavor, if you will, of system that we provide. There's a couple of different options with regards to that. So, but yes, that's what we're seeing from, again, the voice of the customer perspective, where there was a need for being able to do those height measurements very quickly without slowing down the production line, and I think that's what we've come up with here. In addition to that, Trevor, we were able to also, as we go forward, inspect for underfill, height and width, and even LED height and diameter. So there's multiple capabilities built into this particular technology. We're still in a little bit of a pre-release phase right now. This is literally, we've had our demo system here in Atlanta for just a couple of months now, and we're just getting started. You'll hear more from us as the months go by with regards to the official release.
How do you measure the underfill? Are you just measuring the fillet around the side of the device?
Well, correct. Yeah, basically same technology, right? So again, what we can see, what we can measure, if we're unobstructed, we can get through with the laser to the board surface. And again, there'll be more on that as we go forward. A little bit of secret sauce in there as well, right? So we'll be happy to share that at the appropriate time. Absolutely.
Okay. Right. So anyway, Joel, the systems that you've got there, you know, the Koh Young systems, they're all really held together with your K-Smart technology. How has that progressed over the recent months and years?
Sure. Let's move one station over, and I'll give you a quick overview on that as well. So, Trevor, as you're well aware, you know, the K-Smart tools, which again is basically our brain, if you will, for the entire process in terms of data analysis, connectivity from machine to machine. These tools were introduced years ago, and with very good success. And they were individual elements at that time: SPC, remote monitoring, real-time monitoring, link for correlating data. What we're doing now in 2021 with the release of the 2.0 version of K-Smart, Koh Young Smart Factory, is tying all that together into basically a line solution, if you will, and even a factory solution where multiple machines across multiple lines can be fed to a central database hub for analysis and basically fast process resolution, if you will. So you can see a little bit on the screen behind me here where we're adding the element to these individual pieces that have existed in the original release, the addition of the ability to monitor, track, and utilize OEE, basically overall equipment efficiency or effectiveness, as another piece of the puzzle that's telling us what's really going on in the factory. Along with that, now we're incorporating things like reports, customized reports, notifications for out of control situations, much more sophisticated in terms of tying everything together and giving you that single source line control, if you will, entity tool that customers are looking for.
Right, right, okay.
Yeah.
Mike, have you got any questions on this, or are you?
Well, I have to say, I've got demo room envy here. This has nothing to do with your systems, but I've sat through torturously many online demos, and you guys got it down. It's slick, it's smooth, it's good. Not to mention your equipment,
Cool.
but the presentation quality is very good. I don't think anyone's missing out too much on not being there in person. So good job on that.
We've got really good technical people, Mike, and they're making me look not terrible. How about that? That's about
true.
The best you can do with me, so.
Yeah, or as my daughter would say, this doesn't suck. You're doing good.
There you go. There you go. Absolutely. We're very proud of it.
Yeah.
So
you should be.
I'm sorry.
What are some of the challenges of AOI? What are AOI in your opinion? What things can they not do today that you think in the next year or two they'll be able to do without giving away any secret sauce? Where are we headed with AOI?
Well, I think, the software has a lot to do with where we're going to go here, right? Enhanced algorithms for better, faster, all of the above, right? From a information gathering perspective, from a data analysis perspective, we are expanding, as I'm sure our competitors are, at a very fast rate, to include a lot more in the way of through-hole inspection, for instance, right? So there's a lot of things that can still be done just from a capability standpoint that we're working on, and that's again, we're using the voice of the customer to help us drive that, right? What's missing? What would you really like to have that you're not seeing today? Denoising software from an image reconstruction perspective. How do we make it better? How do we continue to make what's already really robust even more robust and more reliable? And then utilizing that information to feed our artificial intelligence proprietary, I should say, artificial intelligence engine to better utilize all of that information and make these systems more intuitive, easier to use, easier to analyze the data, basically more productive and more aligned with basically reducing costs in the manufacturing operation, right? Yields up, costs down, right? Repurpose these people that are utilized today for monitoring any group of machines for something much more productive, and utilizing the artificial intelligence and the automation and the connectivity, the CFX piece, all of that to accomplish that.
Yeah, good point. Can I ask you, Joel, I mean, the K-Smart obviously connects with most of the vendors of equipment out there at the moment. What about if you go into a factory where it's got legacy equipment, and it might even have legacy inspection equipment? Is this only going to work with Koh Young equipment?
So the K-Smart tools, Trevor, are basically just that at this point in time, right? Well, let me rephrase that. As I shift gears here a little bit and give you a little bit different view of some of the other things behind me. You see the MPM printer, the deck printer. From a KPO perspective, and that's another new tool for 2021, the Koh Young Print Process Optimizer, second generation. We're working with companies like this. Obviously, we have them in our demo room. That tells you how the partnership has matured to develop this closed loop feedback entity with their technology. So there's a piece of this, and the mounter element that is currently in development kind of follows the same logic, right? We're working with the usual suspects, if you will, on the mounter side for creating closed loop feedback to their tools for things like feeder, spindle, nozzle anomalies, right? At the same time, some of the tools that I showed you previously are a little bit more Koh Young centric, right? The link ties together our SPI, our pre-reflow, our post-reflow, AOI, and so forth. And a lot of the data analysis that I talked about previously, the OE calculations, are very Koh Young centric. But we are, as you may know, I think if what I've been told is correct, the only inspection company at this point to be fully compliant with the IPC CFX requirements for being able to fulfill all of the events, if you will, from a SPI and AOI tool required at this time. So, you know, we're definitely involved at multiple levels, right, when it comes to Smart Factory Initiative, and that's Dr. Koh's objective. You know, he wants us to always remain the leader in that arena.
Right, right. So one of the key
and is helping us do that, is making sure that we're doing that, right, by helping us fund, if you will, just from a human resource perspective, the time and energy to go do that and spend with those partners to make that happen.
Yeah, well, it certainly has always been out there at the forefront of technology, Dr. Koh. I've known him for many years, even before his days at Koh Young. So
how about that?
Yeah, absolutely. But a very clever man, believe me. One of the areas that is key at the moment, and that Koh Young is very involved in, is of course monitoring the print process. But some of the things that we've been monitoring so far are fairly basic. You know, we're looking at we're measuring the SPI, the volume of the deposits, etc. But the printer itself, there's things like squeegee pressure, etc., etc. How are you dealing with that?
So, well, you put that on a tee for me, Trevor. The next piece I wanted to talk about was that next generation Koh Young Print Process Optimizer tool, the KPO, as we call it, KPO 2.0. And we've had discussions in the past about the three-prong piece to this. We have, starting out at the front end, something we call PAM, which is the process analyzer. That is a tool that will allow you in an automated fashion to undergo an extensive design of experiments for recommendations for speed, pressure, and release pre-production, right? And then the second element of that is what we call PDM, the diagnostics monitor, and that's basically tracking the results and monitoring at a much higher level than the standard closed loop for X shift, Y shift, theta, etc., giving trends information, providing feedback to the user, to the operator, for adjustments that could potentially need to be made based on things that are being seen. Again, hotspots, trending. The final piece to that is what is going to be released very soon with the 2.0 tool, and that's what we call POM, right? Basically the parameter optimizer. So now with the release of that tool, we will have the full capability of not only monitoring the process, but using the machine learning and artificial intelligence to adjust the process through that POM piece for speed, pressure, release anomalies. So now we have the full closed loop control, almost a lights out approach, if you will, with the introduction of that tool when it's released here officially later this year. So very excited about that. We move then to the mounter, where we're undergoing the same types of exercises, right? Working again, as I said, with the usual suspects for development of connectivity, feedback, real-time, self-healing data to be able to, again, achieve this smart factory realization that we're all after. Hands off, lights out. It's not going to happen overnight. We know that, right? But you got to have a goal, and we're working in that direction and making significant progress. So you'll see from us something along that line here very soon as well, with the mounter players out in the market that we're working with.
That's a very significant development, actually, because when we talked historically with lots of the inspection companies, and we talk about being able to adjust the machine. People say, well, they don't want to take ownership of the process. They don't want to tell somebody else's machine what to do. But presumably, you've now bridge that gap. You're working with DEC and other major manufacturers where you trust each other. But
That's right.
are you taking ownership of the process then in making these decisions?
Yeah, we are actually, right? So, but it is a joint effort, right? So there's an element from us that we are providing to the customer. There's also an element from either the printer manufacturer or the mounter manufacturer that goes along with that. So to some degree, there's joint ownership, but at the end of the day, it's our data that's telling the system what to do in both cases. So ultimately, yes, we basically are at that point taking that ownership responsibility.
Mm-hmm. Great. Okay. So the last piece of equipment I think we're going to see today is the Alpha HS, which
Sure.
is the latest AOI system. So can we walk
Absolutely.
over and take? Yeah.
We certainly can. We certainly can. So the Alpha tool is our latest entry into the AOI marketplace. Now, this was introduced just over a year ago, about a year and a half. We've had very good success with it up to this point. The caveat is that we have packaged a what I will call in some people's opinion, maybe a more affordable AOI solution that still contains a significant amount of the very proven measurement-based Koh Young technology that we've utilized in our 8-projection Xena system since the inception, right? So that's been very well received. The beauty in that is we now have a system that can be very well utilized for both pre-reflow and with the addition of a DLP, a fifth projector, post-reflow. And we're seeing that today. We're seeing very wide acceptance on the post-reflow front. Pre-reflow is something that we think we have a significant opportunity with because of the fact that it's still very new for a lot of people. But when we start talking about the Smart Factory Initiative and this feedback from an inspection tool to the mounter, it's coming from that pre-reflow environment, right? We want to pass along very integrity-filled data that's not been affected at all by the reflow process in terms of XY position, presence, absence, all of that. So we see that as a potential driver for pre-reflow going forward in the marketplace for all inspection system vendors. Again, we feel like we're kind of at the forefront with being ready for that because of this initiative to create these mount feedback tools with our partners and again, be at the forefront of that evolution, revolution, whatever you want to call it. The other piece that we kind of folded into that release of the Alpha system was our automated programming tool, KAP, as we call it. The next generation of that tool is also ready for release. And what that is allowing us to do is to not only utilize our existing AI engine library to very quickly come up with a match for packages and components during the programming cycle, but now also to then go into the customer's existing library and do the same thing, right? So the whole point of KAP, if you will, is to build the customer's library quickly. In any inspection realm, the main driver is to build the library as quickly as you can. Once the library is created, programming's a breeze, right? Everything is in there. You're just simply populating it for the next board you're programming. So what the KAP tool does is it allows us to very quickly, between, again, our AI engine, our package library, and the use of the customer's existing package library, continue to enhance, refine, and add to that library, which then accelerates significantly the programming process and reduces the time to accomplish that exponentially. To give you an example, Trevor, brand new customer, no library at all, using our KAP tool, we're seeing match rates of 70 to 80% right out of the gate with the components that they're using. You know, that means what used to take hours to create package types and basically inspection condition files for is now done virtually in seconds, right? Minutes, let's say. But you can kind of get the idea of where that's going and how that's going to continue to evolve. And that's another area, you know, kind of getting back to what Mike asked about, where utilizing the AI to the greatest degree possible. And we have, in our opinion, the best data set, you know, parametric, objective, proflometric, measurement based to do that with, to get the kind of results that we're seeing. So lots of emphasis to be put on that as we go forward as well. And it'll continue to evolve and be refined and provide better and better results.
Yeah, I mean, automatic programming is definitely one of the things that have come into inspection systems over the last year and a half that have really made a big difference. But the fact that you're able to also now integrate your customers' library as well certainly helps us speed that process up as well. And on the, yeah, I also agree with you on the situation regarding the pre-reflow inspection system. I think it's critical to get a holistic inspection process on the line to be able to control the process properly. But historically, it's always been a hard sell to try and get people to buy that pre-reflow system. So I'm guessing that you're probably having to make something that's you know, affordable and attractive in that respect to get people to buy into it.
Yeah, that certainly helps. And again, I think that's what we have with the Alpha series, Trevor. You're absolutely right. It's funny. We have some customers that have been pre-reflow from day one, and some very large customers, for that matter, to be quite honest. And the concept has always been that if they're controlling their print process using the SPI tools, and they're controlling their mounter process using pre-reflow AOI, they feel like they can certainly well enough control the reflow process to the point where nothing should change while that's going on when the board comes out of the oven, and it should be just exactly what it was predicted to be going in. Those people are also now starting to migrate to adding that post as well. And as you had alluded to, the people that were fixated on post reflow from the beginning because they just feel like it gives them more coverage in its entirety, are looking at the landscape and understanding that there is improvement that can be made, can be seen by catching any of those particular anomalies or defects prior to the reflow oven. And then now they're just verifying kind of what they knew or were expecting with the post reflow tool. And then you add together the element of the smart factory realization and all the connectivity and what can be done with tools in the various locations. And it's all starting to build, you know, some momentum in that direction.
Okay. Well, sometime when we have more time, Joel, I'd love to talk about the types of results you get off of the post reflow system. But you know, for now, I think I want to say a very big thank you for showing us around your showroom. As Mike rightly says,
You're very welcome.
It's a fantastic experience, and congratulations to your cameraman, who's obviously using a gimbal or Steadicam to shoot this. And
he's got it figured out. That's right.
He's got it figured out. Absolutely. So thanks, Joel, and enjoy the rest of the show.
Trevor, thank you very much. I really appreciate the opportunity to show you what we have here. Look forward to doing it again. Look forward to getting back together face to face at some point. As much fun as this has been, and as nice as it's been to show you what we have here. Again, to your viewers, come see us. We're open. We'd love to spend more time with you. We could do a deep dive on any and everything that I discussed today and then some. But again, thank you for the time, and I hope the rest of the show goes very well for you.
Thank you. Thank you very much.